Hello and welcome back, guys. So today what we would be studying is stem and leaf diagrams. Okay, so for this we have some data over here. If we remember from our data classes in our previous videos, we discussed the data could be represented in two ways. Data could be either qualitative or quantitative, right? And for our IB Maths AA course, we would be discussing quantitative data. And quantitative data is represented in two more forms: discrete, which means precise, accurate, and continuous, which means not precise. Okay, it usually has a range. Okay, and now there comes the question of how to represent data. Okay, now for example, this over here, this table over here is a way data is represented. This is data for a car park, and we can see that for first week on Monday 32 cars were parked, then 41, then 38, and so on. And then on the second week these much cars were parked. In the third, all these were parked, and in the fourth, these were parked. Okay, but the problem over here is, first let's discuss how can we represent discrete data. Discrete data can be represented in two ways: stem and leaf diagrams. Stem and leaf diagrams, I'm just writing stem over here, and the other is box and whisker plots. I am only writing box over here. Okay, so first of all, let's discuss stem and leaf diagrams. So how do we basically understand these? So what the problem over here is that we have data. All this is data, right? All this is information of all the cars coming in the car park and all that stuff. But this is not organized. This doesn't tell us much. For example, if we want to know what is the largest number of cars, or if we want to know what are the what are the days where it was the most busy or something, we need to search where is the largest number. Oh, this is 56. Then there is yeah, this is the largest number. There's 55 over here, the second largest. And when there was the lowest number of cars, there would be say 30, 20, 21, 22. Yeah, so 21 would be the lowest number of cars. Yeah, so this is problematic, right? This takes a lot of time and it is not very accurate. So stem and leaf diagram provides us with this solution. So the solution is something like, let me just tell you. So what we do is we see the common thing over here. We can see that there are 32, 41, 38, 37, 42, 56. All these common is 3, 4, and 5. Like in the tens place we have a 2, a 3, a 4, or a 5, right? So our cars are ranging from 20 to 50 or 59, I can say, because 59 also has a 5. Okay, so our cars are ranging from 20 to 59. How do we represent it on a box, a stem and leaf diagram? Let me just erase this thing. Okay, so how do we represent it on a stem and leaf diagram? This representation is very simple. All we need to do is, first of all, make two columns. Okay, in the left column we would write the preceding value, the tens value, and that is 2, 3, 4, and 5. There is only the cars are spread on in these values. Okay, so we would just write these. Now if we need to see the all the values and we need to input these in this. Okay, example, first value is 32, which means 3 and 2. So 3 is over here, we'll just write a 2 over here. Okay, the next value is 41. Okay, we have a 4 over here, we would just write a 1 over here. Okay, next we have is 38. Okay, so what we will do is write 8 over here. Then we have 37. I note that there should not be a comma between 2 and 8, there should be a space. Okay, then we have 37, there would be a space, and then 7, then 42, then 56. Okay, 1, 0, 9, 7, 47. Okay, 44, and again 44. Then we have 30, 52, 30, 52, 30 again, 31, 30 again, and then we have 22. Okay, then we have 40. In the fourth week we have 55, 42, 55. So basically the weeks concept is now ended. Now we just are seeing the values 55, 42. Now see, there are so many values of 40s in this range. Now just tells us the most of the time the cars are in the range of 40 to 50. That is how it helps. Okay, let's just complete it. 55, then we had 42, then we have 22. Okay, 22, then we would have 51, 50 and 50. Okay, and now underneath we should write a key. So a key would be that to this 1 means 21. Okay, this is our stem and leaf diagram. Now this tells us a lot of things. You can see that the most are in this range. Okay, then we can see then 30s and 50s are a tie. Then we can see the 20s are at the least minimum. Okay, and what if we represent it in a much better way? So if we represent it in ascending order or in any order, ascending is just like preferable. Okay, so over here like this 1 2 2 is ascending order. Okay, let me just write the 2 over here. Okay, over here the next column is 20, 287, 2870010. We have 3 zeros, 1278, 3 zeros, 1278, 3 zeros, 1278. Next we have this, we have a 0, then we have 2 twos, 0, no sorry, 1 2 2, 0 1 2 2. First of all let's do that. 0 1 2. Okay, then we have 2 4 4 7 9, 2 4 4 7 9. Okay, I'm only arranging them ascending in ascending order. Okay, we have 0 0 1 2 5 6, 0 0 1 2 5 6. Now over here data we have that now we can also tell the range, like the most is 56, the less is 21, and in just an instant what we can do is tell the range is which 56 minus 21, which means that the range is 35. Okay, so this is how compact and how better data is represented in stem and leaf diagrams. For even better accuracy, what we can do is we can write the totals over here. Okay, so 2 plus 2 plus 1 is 5. Then I have 8 plus 7 15 plus 2 17 plus 1 18. Okay, then we have an 18. Then over here I can do is 1 plus 2 3 plus 2 5 plus 8 13 plus 7 is 20 and 9 29. Okay, and then we have 6 plus 5 11, 11 plus 1 12, 12 plus 2 14. Okay, so now we have all these labels over here, and this is our complete stem and leaf diagram. Okay, so now from this stem and leaf diagram we can infer so many things. For example, we could have reduced the range earlier as well. Now we can see the median. Median is basically n plus 1 over 2, right? The position of the median. So first of all, to calculate n, what we can do is we can add all these together, and what we would get is 5 plus 18 is 19, sorry, 14 plus 5 19, 19 plus 18 is 37, and then we have 37 plus 29 at 37 47 57 67 66. Yeah, so it would be 66 plus 1 over 2, and that would give us 67 over 2. okay, which is 3.5. That means the median would be in positions 30, 30, 30, the average of positions 30th and 31st. Yeah. Okay, so to see those positions, what we can do is similar over here. We see 5, then we have 18. 18 plus 5 is 23. We haven't reached 30 and 31st yet. Okay, we'll keep moving on. 18 plus 5, 23. Then we have 29, a larger jump. And then we will get 40. So this means that the 30 and 31st value should be in this range. Okay, so 30 and 31st, we had 18 plus 5, 23, 24, 25, 26, 27, 28, 29, 30, 31st. Okay, so these are the 7 plus 7 and 9 are the values. Okay, so 7 plus 9, basically it is not 7 plus 9, it is 47 plus 49. Okay, we need to take care of this 47 plus 49 over 2 because we need to take average, and that would give us our median, which would be something like 100 minus 4, 96. 96 over 2, and that would give us 45, 46, 47, 48. Yeah, so our median would be 48. So from this data that didn't make any sense, we have converted into this data, which can tell us the mod, the median, and it can also tell us the interquartile ranges. Like if we can calculate the median so easily, similarly the interquartile ranges can be calculated, because the only difference is that for lower quartile the denominator is 4, and for the upper quartile this is 3 over 4 times n plus 1, and that is it. Okay, so this means that this is a very much better representation. In the next lesson we would discuss box and whisker diagram. Up till then, bye bye.